This lesson is going to be about chemical symbols and chemical formulas. In class, we've been working with various substances. We've been working with candles, we've been working with paper, we've been working with chemicals like copper sulfate. And all of those substances are made up of different components. And these components, when we look at the most basic form of those components, we call elements. And each element has its own unique chemical symbol. So for example, carbon is an element and its symbol is the letter C. That matches for the carbon, the C that starts with carbon. You also have something like hydrogen. Hydrogen has a chemical symbol of H. In some cases, the chemical symbol doesn't represent the actual name of the English name of the chemical. So for example, there is sodium, and sodium actually has the chemical symbol of Na. And you notice that there's an uppercase letter and a lowercase letter. In these cases where you have two letters, the reason behind it is we only have so many capital letters in the alphabet, and at some point we run out of letters for how many elements there are. And so scientists have put two letters together. The first letter will always be capitalized, the second one will be lowercase, representing that this is just one element. A chemical formula, on the other hand, is actually a description of how a substance is put together with the different elements. For example, the one we most commonly know is H2O. We know that this is water, and our chemical formula tells us that there are two hydrogens and there is one oxygen. And we're going to walk through exactly how I know that looking at this chemical formula. So let's start with the first example. We have SO2. So first of all, I see that I have two capital letters. I have a capital S and a capital O. And if you go on to page 38 in your textbook, you are going to see the list of the symbols with the elements. So when I look at S, I see that S stands for sulfur. So I'm going to write S for sulfur. And down here, I do not see a number. There's no number over here. And because there's no number, there's the assumption that there is just one of those elements, okay? Meaning one atom. Over here I have O. O, if I look at my table on page 38, represents oxygen. And oxygen has the describing number 2 underneath. That tells me I have two oxygens in my substance. When I draw this, I'm going to draw it in any order I like. I'm going to make a particulate matter diagram, and I'm going to draw an S as one of them. There we go. And then in any order I like, for right now, you're going to draw two oxygens. So I'll put my two oxygens here. It can be drawn any way. You can make it be an S with a O and an O for right now. Makes no difference. The key is that you have one S and two oxygens. So let's take a look at another one. Now this one here, you notice that there's a lowercase letter. Because it's a lowercase letter, I know that it is connected to the uppercase letter. So in this case, I have Na being one element. And when I look at my table, it says that this is sodium. I don't have a number underneath here, so again we're going to make the assumption that there's just one of them. Here I have O again. O represents oxygen. And we again only have, we don't have a letter, so we make the assumption that there's a 1. And then H, capital H, represents hydrogen. And this, again, has no number underneath, so we assume it's letter 1. For drawing this one, I'm going to combine the Na, because remember this is one element, a capital with a lowercase, and then I'm going to draw an O and I can draw an H here, but I can draw it in any order I like. So this is the particulate matter diagram. So let's try something like this. Let me go ahead and erase what I have over here. It seems to have erased that. There we go. All right, for this one over here, I have two numbers. So again, I'm starting with an H. In this case, that represents hydrogen still, and they will always represent the same element. An H will always be hydrogen, and in this case it tells me I have 3 hydrogens. I also have S, this represents sulfur, and I don't have a number underneath, so I know I just have one of those elements, and then I have O, which again is oxygen, and in this case I have 4 of those elements. So I'm going to draw the particulate matter diagram, and in this case I have, again, in any order, I'll put an S here, I'll put maybe 4 O's here, and maybe I'll put some hydrogens over here. Oops, let's make that hydrogen. I'll put a hydrogen over here, I'll put a hydrogen over here. Okay, so let me just make sure that I'm correct. I have 1, 2, 3 hydrogens, 1 sulfur, and 4 oxygens. So there's my model of that. Okay, now things get a little bit more interesting. And here you're going to see for the first time parentheses. So in this case here, I am going to read it from left to right. So I have Ca. If I look at Ca, remember that is just one element because it has one capital and then a lowercase. I'm only looking for capital letters to figure out how many elements I have. So this is calcium. Then I have over here an N. Oh, and with calcium, I have no number underneath. We assume 1. Now, for these here, these are in parentheses. So take a look what this means. So in this case, I definitely have N, which stands for nitrogen. And because it's in parentheses, that means I have 2 groups of NO3. Okay, so for this one, I think it's easier to draw. So I'm going to write calcium as being one of the elements I have. And then I'm told that I have 2 groups of NO3. So that means that one group of NO3 would be N with 3 O's. And because they're in parentheses, you kind of keep these elements together. But I have 2 groups of those. And so that's why I'm going to do another N with 3 O's. Okay? So again, this says that I have 2 groups of NO3. How do I know that they're 3 oxygens? Because of that little 3 describing the oxygens, and there's no number over here. So in terms of total nitrogens, when I look at this, I have 2 nitrogens total. When I look at how many oxygens I have 1, 2, 3, 4, 5, 6. O stands for oxygen, and that works out to be 6 oxygens. I also can use the distributive property and go, okay, N2 and O6 come from 2 times 1, because there's a 1 here, and 3 times 2 being 6. The last one, sometimes you'll see that you have a large number in the front, and that means that you have 2 groups of this entire chemical formula. So in this case, I'll do the drawing first. Keep in mind I have an uppercase K and an uppercase C with a lowercase l. That tells me that this here is 1 element and this is 1 element. So that means KCl, and I have 2 groups of them. And they are not connected to each other. They are separate from each other. So in that case, K is one of those that is not the same as, the symbol is not the same as its name, represents potassium. I have 2 potassium. Cl is chlorine. And this also, we have 2 of those. And that's how you would work through those.